Hello students, welcome back. Let's go to the next problem. We just completed the first problem, and here's the second. The second problem is deceptively similar to the first problem in the sense that we have the same non-homogeneous part, e to the 1/2 power of t, and also the same coefficient structure for 3, -1. Same here. Now what's the difference? This one is second order, so the characteristic polynomial is quadratic. It's the each factor. Now, this one is fourth order, so the characteristic is quadratic. But don't be intimidated. It's quadratic, but it's trinomial. It's not difficult to factor. Nothing like this one. Okay, let's go to the problem. And here's a reminder. This is where we are headed. The solution is the general solution of the homogeneous part plus a particular solution. All the undetermined coefficients will be here in blue part, the homogeneous part, and this one is specific. Remember this because you'll have to complete the partial decomposition. You'll have to complete this decomposition by partial fraction here for red part. For blue part, you don't. Okay, ready? Here we go. The homogeneous part is R of S over Q of S, and it can be factored and decomposed easily like this. I'll be bigger font because there are so many fractions. Okay, all good. Again, you don't have to determine C1, C2, C3, and C4 here. That's not even possible because you don't know what R of S is. They're going to be determined through the initial conditions. Next, the particular part. We have f of s over q of s, and f of s is coming from the non-homogeneous part of the original equation, and it's Laplace transform. And then f of s over q of s, where q is the left-hand side, the characteristic polynomial. Therefore, there's nothing undetermined here. We have to get it, and we have to get complete coefficients here. And then that's what I did. Take it apart through the decomposition by partial fraction. Did I say you have to get complete coefficient? As a matter of fact, no, to tell the truth. I mean, this one you have to get completely. These, you don't, as a matter of fact. By the way, this is how I got it. Apart command. Remember this? Okay, why are these not so important? That's because they're going to be absorbed into this homogeneous part. This part here will be absorbed by the first fraction. The second fraction will be absorbed here. And this one will eat off the third fraction. So this is undetermined coefficient C1. So C1 minus of 18 over 25, that's about it. That's another undetermined coefficient. Here, C2 plus 2/5, and that's it, isn't it? 2/5? I don't think it's 2/5. Oh yes, it is 2/5. Amazingly simple. Okay, all right. And so on and so forth. So basically, C1 minus 18/25, I can take it as another character, say K1, and then just move on. So what's the moral of the story? That's the important part to be determined. The others, they're going to be absorbed into homogeneous part. Okay, let's go to conclusion, and here's the solution. The homogeneous part plus this important part, and then if you add them up like this, upon taking the Laplace inversion, you have the complete solution. Here's checking by Mathematica. Simplify the left-hand side. By the way, this command here is the fourth derivative. I mean, you don't want to take this prime 4 times. So d is a derivative. of y of t and then take it with respect to the variable t 4 times. Okay, anyway, that's mathematical command, and that's a complete solution. Now, the problem is complete, and I have just one comment here. If you want to be really precise on everything, and precise in the level of college algebra level, in that sense, this C1, C2, C3, C4, and these and those should be different. Why? Because this C1 ate up this coefficient, so C1 minus 18/25 should be over here. And then upon taking the Laplace inversion, because of this 2, you have to divide by 2. So this C1, and that C1 are actually different, all different. Same goes to C2s and C3s and so on. So what's my choice? Do I actually do all these computations and put those in and get messy expression here, 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 and there? Hey, what's the point? What I want is simplest possible expression in the end, so that's actually counterproductive. Another way, shall I change characters? C1, C2, C3, C4, and then change it to K1, K2, K3, and K4, and then now another character. What do we have? J1, J2. Oh my. You soon run out of character like this, especially considering that in your project you may have 3 or 4 differential equations flying around, and this is just the intermediate step, and soon you're going to be swarming with all those different characters. And that's really counterproductive. So the general convention here is just using the same set of characters even after absorbing some constants and absorbing some division here. That's the general convention. Our textbook author does not do that. He preferred to do it in really strict college algebra level, strict changes. But, well, I decided to do it here in a little bit more general engineering or applied math level of convention because it's more convenient. And then you should know those kind of things as well. Here, I had to change twice, but the maximum I've seen in this course is 4 times. Having to change the characters 4 times in a single problem. Those kinds of problems show up in chapter 7. And then you begin with C1, C2, C3, C4, and then change it to some other character, another character, another character, 4 times. Come on, it's too much. So generally, it's a good idea to keep the same characters whenever you have to absorb some of them into new set of undetermined coefficients. Okay, all right. So much for the digression, and let's go to the next problem. Problem C. Now, this one is going to be 5th order ODE, so the characteristic polynomial here is going to be quintic. Can we actually factor it? Well, yes, you can, but I don't recommend it. I'd much rather use Mathematical's computation for that, and this is basically what I did. Let's see, let's expand the font. There are too many factors here. Okay, so this denominator here is the characteristic polynomial, and if you factor it correctly, you're going to get like this. S plus 3, 2s minus 1, total quantity squared, and s squared minus 2s plus 5. How did I get that? Factor command, and then this is what Mathematica spits out. Oh, by the way, another interesting command, expand command, that does the opposite. Copy and paste this one, and then let it run, and you're going to get this one. So I use computer algebra system to factor the denominator, and then let's decompose it by partial fraction. But there's one more thing to do. This quadratic irreducible, I can take the complete square like this, s squared minus 2s plus 1, and then plus 4, so that we get this denominator down here, s minus 1 squared plus 2 squared. Why did I do this? Because there's better association to the complete square, as you see down here. as you see down here. That's why I did it. In the end, this is a Laplace inversion. And this is the general solution of the homogeneous equation. Alright, let's find the non-homogeneous part, something to add to this. So what we have capital F over Q, and capital F, from sine of 2t, we get the Laplace transform of 2 over s squared plus 4. Here, this formula here. Okay, and then take f over q and simplify. What did you get? We gained this new factor here. So when you take the decomposition by partial fraction, you get this important term, which comes from this new factor, which highlighted in red, and all the rest, which are, as a matter of fact, the repetition of the homogeneous part. I wrote everything here, but to tell the truth, it's not really necessary. You can simply write like this. And then just move on. That's totally fine. By the way, how did I get all those numbers anyway? From Mathematica. And this is the important factor. Let me highlight it in red. That's the important factor. And then I got it over here. Okay, let's add those up. So this plus that is gonna be capital Y. Oh, I just went directly here. From here, take the Laplace inversion and then we get this part. And then all those previous ones, I just copy and paste from here. And then that's my solution. And I can check through my Mathematica command like this. Simplify the left-hand side. Fourth derivative, third derivative, second derivative, first derivative, original, and so on and so forth. And you get the right-hand side, sine of 2t. Okay, again the same comment here. In the most strict sense, this C1, C2, C3, C4, and those are different from these. But I wouldn't bother because they are undetermined coefficients anyway, so I wouldn't really bother. Okay, so much for this example and so much for this section. Let's do section 3 in a separate video. Let's stop here.